Live now on YouTube, I believe. Is that right?
All right. Hello and welcome, everyone. Tony, you want to kick off our intro there?
Yep, coming right up. Okay, let me do it again.
Oh no, we're not getting Mr. Wilkinson.
Oh, we're not getting Mr. Wilkinson.
Maybe if I think all of our students, if
are you hearing it?
We're not.
No.
Yeah.
Oh.
Well, here's the deal. I think some of the students have been here before. You know how we say the legumes in space? Why don't we do a countdown, 3, 2, 1, and we all say legumes in space. How's that sound? You get to unmute your mics now, but then please go on mute after we do this, okay? All right?
All right, so hit unmute.
Right.
We'll give everybody a second to hit the unmute themselves.
We'll do a countdown.
All
and
right,
on after 1, we'll say legumes in space, and then we'll go back on mute, all right? How's that sound? Wonderful. All right. 3, 2, 1.
Legumes in space.
We'll need to work on that. That's pretty good.
We'll work on that.
Michael Wilkinson, but that'll have to be for today. Over to you, Lauren.
Oh, well, we tried. Sometimes technology works and sometimes it doesn't. But thank you, everyone, for joining us around the world for today's edition of Legumes in Space Live, as we are reaching our real collaboration stage and want to hear from plant scientists around the world. And those are you. You are the plant scientists. So if you have just joined us, make sure you type into the chat where you're from, and also type in to tell us whether or not you have nodules on your plants yet. So we have a lineup today with some classrooms, teachers, and students from around the world who are going to talk about how they have been investigating with clover in their ground trials paired to our flight experiment. And so we're excited to be able to hear from all of you and what your experience has been. What are you curious about? What are you observing? What have you noticed and written down in your observation logs? Are you seeing certain patterns? You know, did most of the nodules show up on a certain day after planting? This is your opportunity to really showcase what you've learned through this experience over the last month and a half. And we still have our experiment powered up on the ISS. And so you're still able to go on the platform and view what's happening in those tubes. You can see the fixative that has been inserted through that green tube. And we still have one tube hanging out there that we haven't called for the fixative yet on. And so we're still holding out some hope that maybe that little guy down in the bottom of the tube will show us some nodulation as well. So Ted, do you have anything before we kick off and head off for our tour around the world?
Yeah, I'm looking forward to this tour, everybody, and hearing what you guys have got to share with us. I did want to mention, I don't think we've actually seen the time lapse of the second tube filling. So maybe sometime during the show here before the end, we can watch that animation of, or I should say the time lapse of tube number 2 filling. And it looks a little different than the first tube we did, tube number 3. So anyway, I just wanted to mention that so we can cue that time lapse.
Perfect. Yeah, Tony, if you can get that lined up for us. So our first stop on our grand tour is to Romania. And do we have Ms. Stoica here to kick it off for us and to introduce some of her students? See, you can go ahead and
Hello. I am Yana Stoica. I am a physics teacher. Greetings from Bucharest. Allow me please to introduce my students, Maria and Andrea. Maria,
yes,
please present our project.
Sure. That would be us. So once again, hi everyone. My name is Maria, And together with my colleague Andrea, we'll be presenting the results of our ExoLab-8 ground trial up to now.
We're currently in grade 9 and we're students at the Tudor Viano National High School of Computer Science. And Maria, why don't you start with our findings so far, and then I will talk about the planting process.
All right, sure. Let me just see if I can share my screen. All right. I think you can see now, right?
Yes.
Yes.
Okay, that's great. So exactly today we got to the end of week 6. So we thought it would be interesting to take you all on a time trip from to see the 6 weeks of growth of our clover plants. So we're now starting at the bottom with week 1. And this is my first sketch that I've done with the comparison of the seedlings. We have here seedling L1 and the one that is called King Cobra on the ISS. I tried to represent somehow the most important events in week 1, and I think that would be the germination, of course, and then that the cotyledons appeared, and also the radical got very long just in the first week. And on the other hand, the seedlings on the ISS also had a very good evolution in the first week. I think it was maybe the best week for them. Now we're reaching week 2, coming to the second sketch. And first off, the growth stage advanced to a singlet. I tried to draw somehow some spikes on the stem over here. But more importantly, the most important event that happened during week 2, and actually I'd say the most important event in our whole project, would be that the first 2 nodules appeared in our case exactly 14 days after planting. And whereas on the ISS, we noted that there were the first 2 leaves appeared. Now here is the week 3 sketch, which was a very good week for our plants inside the school ExoLab. The first trifle appeared, but also we saw some very important changes in the root systems. They started branching a lot more, and also from 2 nodules we got to 8 actually. On the ISS, so we didn't see many changes. There were only some color differences from last week. Now, also, I tried to include some pictures from my trial at home to see a bit of a comparison. And talking about the leaves and stems, if you remember the previous sketch, they are quite similar. Like they were 60 to 70 millimeters. And this picture was taken in my jar that had rhizobia. I also have another hypothesis that did not have access to rhizobia. And if we were to compare these roots of week 3 to what I showed you before with 8 nodules, we see that the ones without rhizobia are very different. They have no branches, no nodules, and also they are they are a lot smaller at 30 millimeters. And now I think this is one of my favorite pictures that I've taken, because I think I captured the exact moment when the first trifle emerged at my clover plants at home. And also it's very close up, so you can see all these spikes in here. This happening 21 days after planting. All right, so then we're reaching week 4, which was not the best week for our plants. Actually, I called it like stagnation week, because even though we have had a slight increase in height and the roots started branching a bit more, there are not any growth stage changes or anything more significant. And talking about the plants on the ISS, so there are just some slight color changes that we recorded in here. Now, what I really found interesting in week 4 was this little comparison between the plants in the magenta light tube and the ones in the white light tube. So we try to capture that if you were to count the nodules, the one in the magenta light are about double the ones in the white light tube. Also, if we analyze the size, maybe if we're looking at this nodule over here and the one in here, we really observe that the ones in the magenta light are a lot larger. And another advantage for the magenta light tube is that the taproot is even longer. Actually, it's 20 millimeters longer, so reaching the bottom line of the tube. All right, so I think for those who are in the previous lives, I talked a bit about what else we all wanted to analyze at school. We have another tube, separate tube in a double magnetic field. And up to week 4, we had not observed any nodules. But what seemed quite interesting to us was this plant over here that is making a loop at the bottom. So it doesn't have a straight root. Whereas the plants with the double rhizobia quantity, I think it's pretty visible in here that, the roots are at that point of separation between the air and the growth media. So the probability of nodules to appear there got smaller than we thought at the beginning. Week 5, so if I said that week 4 was a bit of a stagnation, week 5 was actually amazing for us. Many new nodules appeared, and also they had a bigger size. These pictures I added here were taken by us 35 days after planting. And let me just go back for a second. So seeing that in the magenta light we have way more nodules than in white light, I thought, why won't I just apply that to my plant at home as well? So then I built this little growth chamber, and somehow I managed to improvise the magenta light. And I put together this student lab at home. On the walls, I have some sketches that I presented earlier and any other materials we have at school. And but most importantly, you have already observed here the 3 work hypotheses. The first one with rhizobia, the amount that you told us in the protocol. The second one without rhizobia. And also another one, which is a bit more new, a combination between agar and potting soil. And now we're reaching week 6. We're reaching the present moment. So these are the pictures that we have taken, that we took yesterday. And if in the previous weeks we edited the pictures, so we tried to circle the nodules and much more. We thought that this week we'd just leave the pictures raw because we thought they looked really great. For instance, this one, also this one is a personal favorite because you can see that the nodules are very large, very long, even compared to the previous week. We have more nodules, and also they have an increased size. This picture being from the magenta light tube 41 days after planting. And seeing these many nodules in the magenta light, that's why we didn't take another picture for the white light with fewer nodules. But then we have the other special tubes that we talked about earlier. But they were not as successful in terms of achieving root nodulation. But we are still very happy to take observations on them. And also in the tube with a double magnetic field, we are delighted to observe that finally our third seed has germinated. So that was good news. And now, in the end, I have another conclusion. As I was talking before about my plants at home, the one that from which I really drew a conclusion was the one without rhizobia. As you can see in this picture, this is the first trifle, second trifle, and also the third one was coming out, so it would be there pretty soon. There was in here also, they look pretty long. They are vigorous. So also the third seedling has two branches, but we have no root nodules. So comparing this to the ExoLab device where we also have magenta light, so the only parameter that is different being the rhizobia, then we can say that in the end we have observed that rhizobia really determines this appearance of root nodules. So without the rhizobia, we didn't have any chance to reach root nodulation. And now also one last conclusion that we have would be that the most beneficial environment for our plants would be the one in the magenta light and with the amount of rhizobia that you specified in the protocol, with the mention that we can also achieve root nodulation in the white light tube. And we actually thought it would be a good way to end my part of the presentation with this picture where you can really see the nodules. And now one more thing until Andrea will jump in. Let me just change to a different window. All right, I think you can see the different window over here. Here is our website that I tried to present a few sessions ago. It's at vianoprojects.com, and here if you click on ExoLab-8, all right, you will be you will go to another window which presents our ExoLab-8 project this year. And we made this website to share our experiment and findings with other people that are interested. So I don't know if you ever have time and would like to see some insights of our project, you can see many pictures and observations and everything else. All right, let me just stop sharing right now. And as we said at the beginning, we documented the planting process. So I don't know, Andrea, let's see how that went.
Thank you, Maria.
All right, I'll prepare this for you.
Okay, so on the top left corner of my part of the presentation, we can observe our mission patch that we designed. And now we can jump in to the planting process part of the presentation. And here I prepared a here I prepared a table of contents, and that contains the steps that we took for preparing the ExoLab tubes, and those are preparing the Agar, preparing the rhizobia, and setting the ExoLab tubes. Here we have a few pictures of us preparing the Agar, and then of us preparing the rhizobia. And then I will talk a little bit more about setting up the ExoLab tubes. The first step of preparing the Agar was analyzing the planting steps, and you can see us doing that on the left side. And the second step was pouring the distilled water. And then we microwave the water that will be used in the growth media, and the process is going to be repeated after adding the agar powder. And the fourth step will be preparing the agar-agar. The second part of our planting process was preparing the rhizobia, and the first step of that was putting the rhizobia powder into water. And then we had to homogenize and stir the solution, which was particularly difficult because the rhizobia powder is hydrophobic, and it was a little bit of a struggle to get it to dissolve. And the last part of the planting process is setting up the ExoLab tubes. And the first step of that is pouring the rhizobia into the tubes. And the second step is pouring the agar-agar also into the tubes. And finally, the last step is holding the tubes at a slant. And you can observe that in the picture where Maria is holding the tubes at an angle. And this is the end of my part of the presentation.
All right, thanks. So now, also in the end, I think we would like to point out that we really enjoyed being involved in this project and also recording daily observations, analyzing our red clover plants, and most importantly, acting like real scientists.
Oh, Maria and Andrea, yes, you are not acting like you are real scientists. That was phenomenal. What a tremendous experience with you took the protocol and then you had other questions. You're like, I wonder. You were curious. And so you found ways, even while you have your main experiment running, to run these side experiments to test other questions. And so you really took this project to an entirely new level. So you girls have done a stellar job going through this process and designing the experiment, following those base instructions, and then redesigning the experiment to test something new. And so we are thrilled with how you have excelled in the practice of science and learning along the way and reaching these conclusions based on evidence and observation. And so congratulations on your achievements throughout this process. And you have a tremendous path ahead of you in astrobotany. We really hope that you have been really launched and inspired to continue the work in this field. Plant and space biology is a growing field, and so you are definitely a shining, both of you, shining stars, your entire team, and under the leadership of your teacher, it's been phenomenal to see your progress over these weeks. And so thank you for a fabulous presentation.
Yeah, Lori, if I can, I'd like to echo that. Wonderful job, guys. And also what intrigued me is you started experimenting with some soil. And I think, Lori, we're considering our next mission in August to be thinking about how might we grow these legumes using lunar regolith or maybe Martian regolith. So the rock and the aggregate from, it's simulated, obviously we can't bring it back from Mars or from the moon, but it's what we understand those chemical compositions to be. And so you're in a way, you kind of jumped in front of where we're going, which is fantastic. Really excited, and hopefully you can join us in our mission coming up in the fall. So thanks again. I really enjoyed the presentation.
Yeah, it looks like once Maria wants to know, yeah, what's the website? So Maria, perhaps you could type that web link into the chat for everyone so that they can save the link. That'd be awesome.
Right now.
Great, perfect. All right, so I think the next stop on our tour is going to be down in Texas, and we have one of our PIs, Mr. Javier Montel, with his group of students. Let's see, Javier, are you available now? Is this a good time based on your class?
Hello, yes. Hello from Freeport, Texas. And I'm very excited, guys, to share with you what we have been working so far. And the interesting fact that we're working on is that these kids are kind of new to science. These are kindergartners and they are bilingual. So they're doing an impressive job. So let me share with you a small presentation about what we have been doing so far in our journey. Okay, guys? So we are in the district of Brazosport ISD. Brazosport ISD is near the coast. We are down from Houston like 45 minutes to an hour. And we are a group of 5 teachers. It's Miss Serna, Miss Acuña, Miss Sepulveda, Miss Huey, and Mr. Montiel. We have one class that is virtual and the rest are face-to-face, but we are sharing our resources. So we are communicating on every other Friday so we can discuss our findings and do some lessons, okay? So of course, guys, everybody was excited when we launched our experiment to space, including my students. So I gave instructions for the parents to see the launch and the docking, and we saw some videos whenever that happened. So it was very, very exciting because for small students, this is kind of something that is unbelievable sometimes for them. So let me move just a little bit here. Okay, so as I was telling you, our program is for 2 schools. We are participating 5 teachers and around 70 students. In our journey, our platform was supported by 3M. 3M is a partner that has been here in our district. And this is the first time they founded a program. And they were very excited because it was about how to leverage science through language arts and to reading and writing and math. So this was a very interesting approach for the company. And they decided to sponsor our activity for our 70 students. For us, what is interesting was to make the invisible visible. Growing plants is something that we usually plant a seed and then on the next day the plant might grow. But with the help of the ExoLab, we're able to freeze the time and see little by little how the plant grows. And another important element for our research is the idea of the bacteria and also the viruses and all that kind of stuff. So we kind of did a cultivation of bacteria using our hands. And for the students to understand what was the bacteria, we have to make it visual. So we conducted a very classic science experiment here in disc A. We didn't have any thing, just the agar, the same agar that we have in our experiment. Letter B, I think we touch the agar just with our bare hands. In letter C, I think it was, I have the data here. We have, okay, we have disinfectant, we have Germex, and in letter D, we have soap and water. So we were cultivating our germs over there so we can see what a germ is and how they grow, because telling the students that are very little, hey, there's some bacteria what is a bacteria? So they were able to see how the bacteria was growing inside our ExoLabs. So next, we recorded everything. We were doing some observations, and we were recording everything in our little portfolio. Oh, that's Claudia. I think that's Claudia. Right? Oh, they're asking who is that girl? No, that's Claudia. And we were drawing, we were writing, but the interesting fact is that at the beginning, the students didn't know how to read and write. So first they were copying, and then eventually you can see the progress of their writing. Guys, hey, let's listen. We saw the progress of the writing from day to day as well, because at the beginning they write just a little bit, and in the end they could write a little bit more. So that was very, very impressive for our students. And of course, speaking about space and the International Space Station was also a very abstract concept. So in our kit, we also got the ISS above, which is a small device that you can connect into a projector or a TV, and you can track the International Space Station. And whenever the International Space Station is above you, it will blink to let you know that the International Space Station is above you, so you can either go outside or you can plan whenever there's gonna be a flight nearby. And we were also learning about that. We in one of our lessons, we visited the International Space Station with the help of our computer, and we were looking for the tools and toys that are actually in space. And we discovered very interesting things in the International Space Station. Do you remember the toys that we discovered in the International Space Station? What were the toys? A little plushie. Okay, there was a little plushie. What else? A ball. What else? Stickers. Stickers. What else? A car. And there was also a little Santa Claus that we discovered over there. So whenever you have time, you can go over there and look for it. So that was something that was very abstract, but when the students were able to see where the plants were gonna grow, they got very, very excited. Also, what we have done so far is train the students to be good observers, okay? By being a good observer is the first step to be a scientist. And since the students are very new to science, it is very important for them to train their eyes. And one of the exercises that we did, guys, hey, look loud, is actually compare and contrast seeds. And we did the seeds from our experiment, which is the clover, and we compare and contrast with a similar seed, which was mung bean. So they can see and train their eyes to find similarities and differences, because those are the tools that are gonna help you to discover new stuff. Just like the guys from Romania, I was very, very impressed that they are very clever observers, and sometime and some way it has to start. And why don't we do it since kindergarten? So we train the eyes of our students to make discoveries that are very, very tiny, just as small as a seed. During our journey, we started to write about how we did everything. In this case, what we did was planting our seeds following the protocols, and we also here illustrated and write about what was the process of planting a seed for a ground trial. Next, it was visualizing the phenomena of growing the rhizobium and the nodules in our experiment. So what we did here is that we had several sessions with other teachers here, and we share resources. Guys, listen. I know that you're excited to see your friends. Okay, so we compare and contrast the how plants grow in space and Earth, and also we were discovering with our eyes and magnifying glasses and everything the nodules. So this was the first time for them and for a lot of us to discover nodules in our ground trial in our ExoLab. Also, we use observation as a science tool. Right here outside of my classroom, this is a small observation table where we have different seats with different how can I say this environments and also variables. One of them, for example, have rhizobium, the other doesn't have rhizobium. One of them have a little bit, the other one has more. One of them doesn't have seeds because one of my students discovered that if she didn't put seeds, the plant won't grow. So the plants of our students were growing and growing and growing. And then she began to notice, hey, why my plant doesn't grow? And I noticed, and I left a couple of days until she realized that if you don't put a seed, your plant won't grow. And of course, they are discovering nodules. They have been counting, they have been writing, they have been illustrating the phenomena. And also, this is a display that is outside of the classroom. So whenever they go outside and they go in, they stop over there and begin to notice some stuff. Some of their plants, for example, have fungi. Can you share your plants with us? Okay, so this is my friend Luis, and he discovers something very interesting right here. Can you tell us a little bit, Luis, what we can observe here? I'm gonna stop sharing. Can you tell us what you discovered? ¿Cómo se llama esto? Nódulos. Nódulos, okay. And what is the white thing here? ¿Cómo se llama la cosita blanca? ¿Cómo se llama esto blanco, chicos? ¿Qué le está pasando a la planta? Okay, so he discovered that his plant was dying because in one of the experiments, we have fungus in our plants. Who have fungus, guys? Just two, right? Oh, no, just him. This was the only plant that have fungus in our ground trials. So it was very interesting that just him got the fungus and the other ones don't. Even though we have the same environment and the same planting procedure. Thank you. Christian, can you tell us a little bit about your experiment? Was one of my favorite students because he talks a lot. Let's see, he's not shy today. Okay, can you tell them a little bit what we have learning so far?
It grows a lot.
Grow a lot, right? What is this?
Noodles.
Nodules, okay. So he discovered nodules as well. And how many seeds do we put? Do you remember? How many?
Three.
Three, just as the plants in the International Space Station. Thank you. And let me see. I think that's the last slide or one of the last ones. Hey guys, so that was our presentation. You know, to be a scientist, just like the team from Romania, you have to start somewhere and you have to start somehow. And this is the first time for our students to observe how a plant grows, because as I was telling you, sometimes we plant the seeds and the next time is like a full grown plant, especially with the lima beans that we usually plant in kindergarten. But you never know when you can start inspiring students to be scientists or astrobotanists, and that has to start somewhere and sometime in our lives. Thank you, guys. I don't know if you have any questions.
That was phenomenal for you to take this project of sending an experiment to space and make it real and doable for students who are just starting their education. That is significant because they will remember forever as kindergarten as the year that they got to have an experiment in space. And that sense of wonder and curiosity, you have cultivated that in them, and they are going to go far because you have been a rock star teacher and mentor to showing these kids that what we think is impossible for them to understand at a young age, they've embraced it. And to see their writing progress in that way and taking measurements and using all these different scientific skills and applying it, and they don't know that they can't do it. They just were soaking it up, and we see that in the classroom and in all of your pictures. So absolute kudos.
Yeah, so inspiring, Javier. I want to be in your class. You know, the German word for kindergarten, it translated is children's garden, right? So I'm just thinking, German, das all Kindergarten is the garden for children in space, right? So you basically showed us das all Kindergarten. So thanks so much. I don't know if any of our friends from Germany are there, but I'm sure they'd appreciate it. Wonderful job, guys. So excited that you joined us on this mission. We're very, very proud of the research that you've done.
Wonderful. And now we are going to journey over to Fort Collins, Colorado, to Weber Middle School with Mrs. Kearns and her sixth graders. So if she is on, you can go ahead and pop your mic on. Welcome.
Thank you. Hello, everybody, and thanks for those wonderful talks. The gals from Romania in high school, wow, you are so professional. And we've been following Javier's class for many reasons. Number one, so many root nodules. We're so jealous. We've been waiting for our plants to nodulate the way Javier's class has done. And also following the amazing technology that he's been doing with his little kinders. They have been using co-spaces, and they've been using augmented reality. They've been doing wonderful, wonderful things. So good job, everybody. So here we are in Fort Collins, Colorado. We're halfway between Cheyenne, Wyoming, and Denver. And I have 3 classes of 6th graders, but today you'll be joined by my 3rd period class. We have a totally different approach than the other schools. We only learned about this program maybe 2 weeks before it launched from Wallops, and we were able to get our supplies and get everything going, but had never heard of this project before. So we have an interesting school program here. It's called the WAVE program, and it's Weber Aerospace Adventures in Education. And so since 1992, our school has been running simulated space missions, astronaut missions in a space shuttle that we have in our school. And it's a very lengthy process, a very coveted process where students have to apply to become astronauts. If the students are astronauts, they get to spend the night in the space shuttle here on campus, which now we've converted into a rocket since the space shuttle no longer flies. And we have mission control specialists, we have communication specialists, we have scientists on board, and it's a really big deal. But because of the pandemic, we were not able to run our program. So when we saw that this was a thing, we thought we've got to do this year, and we can then use our ExoLab going forward for those actual space programs and experiments that we do in our WAVE mission. So our procedure has been different. We don't have any slides to share, but if Weber Middle School students have their cameras on, everybody go ahead and do a wave. And we have 3 students who are going to just do a quick short presentation on what's been happening in our classroom and what they have been doing with the seedlings. So Sawyer is going to go first, and Sawyer, you can turn on your microphone and you can take off your mask.
Make sure you're unmuted, Sawyer.
Oh, I think we see Sawyer, but we can't hear you, Sawyer.
Yeah, Yeah, he's going to come over to my camera. We don't know why his microphone isn't working.
Okay.
Yeah, he's not muted.
Hi. So what I'm doing today is I'm talking about, so we did a project in our class where we painted our plants. We didn't exactly paint them, but we're talking about, so like we were really like just doing watercolors, that's what it's called. And we were painting our plants, so yeah.
Show from the beginning to the end for that first piece.
Okay, so this is the first picture that I have. It's on day 3 of our plants planting. And then this one is about our L1 plant, which is our first plant. And our plants have grown like very differently from each other because this, as you can see, they have grown very differently because the seed that is mostly targeted on this picture, it has barely grown, and then the seed in the middle is like very different. It's grown a lot, and then on this picture on day 4, it hasn't grown a lot. It's barely sprouted, to be honest, and it's just a lot different from these because as on day 3, one of these are bigger than one of the. Okay, sorry. One of these, the middle one, is bigger than this, which is very interesting because it's been on day 4. And then the second one is on day 2, which is even earlier before those 2 pictures. And this plant has grown quite a bit, surprisingly, even though it's just been the second day. And I think that's very interesting because they've just grown very differently in different ways. And then on day 1, which I think is the most interesting, is this because it's surprisingly, because it's just been 1 day since we've planted them. And it's just, I think it's fascinating how they can grow so fast.
You saw rapid change in that plant within just a few hours. And, you know, it's remarkable how they do grow at different rates. How some seeds are a little bit slower and others you immediately get it in that media. And within just a little bit of time that radical's popping out. And I love how you captured some of the color of it too.
Okay, so the last picture that I have is the last one closest to the one that I'm studying. It's R2, so the second right one, and this is on day 2. It's kind of grown, but it's still stuck inside the seedling. So it's very interesting to me about like just again how they grow and yeah.
Yep, and sometimes you see those seed coats, they get trapped around the leaves or trapped around the root area. And so they will shed that off in different ways. So great observations. Good job, Sawyer.
Yeah, I love the art, Sawyer. Our friend, Mr. Wilkinson, loves the watercolor. You might have seen some of his work as well. And I'm sure he'd really love to see it. And I'm sad he's not in the show with us today, but he's going to watch the video and I imagine he'll have some comments about it as well. So great job. I really love that observation of how you're translating what you're seeing to something you can share with us. So thank you for that.
Okay. Yeah, so I'm going to be passing this over to my classmate, Isabel. So, goodbye.
Bye. Great to see you, Sawyer. Thank you.
Thank you very much.
All right. Isabel's up.
Can you guys hear Isabel on her camera or no?
No, I don't hear her.
Come on over to mine.
So I'm going to be doing the exact same thing, but with days 5 and 6.
Isabel, are you able to tilt the camera just a little bit lower so we can see you a little better? There we go. Thank you. That's great.
So I need to find one that actually has one. Okay. So this one is day 6 L1, and it's grown a lot over the past 6 days, which I think is really interesting how fast it grew in just a couple of days. It already has its root into the agar, and it's already dropped the seed coat, which I think is really interesting because of plants usually don't grow as fast as these ones did. None of these. So none of these have. Doesn't matter. But so this one's another one from day 5. I don't know which one it is, but it's from day 5, and it's grown a lot over the span of 5 days. It doesn't show a seed coat around it, but it already has its leaves sprouted, so the seed coat isn't on it anymore. So, and then this one was recorded for March 10th, which I believe was day 6. But it already has roots into the agar, or roots into the agar. And it's already grown. It was already starting to grow beautifully, how it's supposed to.
And even some branching roots, it looked like.
Yeah.
The last one, pass it over to our last speaker.
This one's another one from day 5, and just like all the other ones, it's growing really well and really strong and beautiful. And then I'm gonna pass it over to Ethan.
And Ethan, why don't you just come up to mine so some of the microphones seem to be
Wonderful. Thank you, Isabel. Nicely done. Having that artistic eye and noticing color and size and the shape of the leaves, all of that adds to the research as we look at the factors of how these plants develop when they have the rhizobia or when they don't. So, all right, well, welcome. Tell us what you know and what you've learned.
Hi, I'm Ethan. So this one's R3. Actually, it was our last one to sprout, but it's doing well now, and it's pretty cool how much it's grown.
How many days after planting was that one?
That one was day 24.
Okay. Very solid green color, very healthy plant.
Yeah. This one was day 26. I'm not sure which one it was, but it was day 26. It looks like it's doing very well. The cotyledons, like the first trifoil, is sprouted. And it looks very healthy. This one, I'm not sure which day or which seedling, but it was 326, and I think it looks pretty healthy.
So, especially with all of those branching roots down there, yes, that means it's definitely getting down in the media and getting nutrients and water.
This one, I'm pretty sure it was day 21. I gotta say, it looks really healthy.
And the stem, tell us about what's happening with the stem there.
The stem appears to
be turning red, which I think is why it's called red clover.
Well, the red does eventually show up in the flower as well if you get to the flowering stage. And so sometimes those pigment colors can give us a sign of the different micronutrients that are showing up in the plant. And those little hairs that develop on the stem as a defense mechanism is also a good sign that it's growing healthy and trying to mature. Well done.
So we have to go to lunch, but we do have one other really kind of cool thing that's happening with us right now. We've been watching everybody else's plants and comparing, and we finally thought maybe, just maybe, we might have nodulation. And it turns out that on our R1, which actually is in the magenta, so when we were listening to Romania talk, we're like, oh, that one, it gets more magenta light. Our R1 has its first nodule. So while we've been doing our other studies here, and this has kind of been a side project, our kids are just logging data every day, watching and observing, and that has been our take. So thank you for letting us be a part of this, and we're excited to hear about what the other schools are doing. So thank you.
Awesome,
Bye-bye.
Tricia. We love that so much.
Congratulations.
You know what would be wonderful is a portfolio of all the wonderful artwork. We only saw a few students. If the other students could share their work, we'd love to see it. Thank you so much for that.
Thank you. Bye-bye.
Bye. Thank you so much.
You.
Wow, what a tremendous experience for the students in Colorado as well, to take what we would normally think is just a pure scientific observation and really use artwork to showcase and track their learning. And I think through all three students, they noticed, oh, how important it is to write down the days after planting, the date of the plant, which one that they're tracking. And so with each time that you do a science experiment and investigation, your practice of science improves. You build upon what you know from doing it the first time, and you get better at it each time. And so many of you have clover seeds left over, and I know that you can take some inspiration from the projects that have been done and showcased today to continue growing clover in different media or to answer different questions now that you're curious about how a particular variable or factor would affect the growth of the plant. Tony, do we have queued up before we sign off for today the time lapse of tube number 2?
Yep.
We want to take a look. If you recall from the filling of tube 3 with the fixative and what happened to that fixative, I want you to notice what is similar and what is different about what happens when we see the fixative in tube number 2.
Can you see my screen?
Yes, there it goes. So we have that fixative coming down the green tube, that bubble, you see little air bubbles within that big bubble forming, and it's getting bigger. It's still latched on, and then it popped, and a new bubble starts forming.
I love the way the light bends here, and we basically have a magnifying glass for a moment.
Absolutely. So that's Oz, the seed that didn't really develop very much back there, and we get a magnified view of that seed as these fixative bubbles grow larger, and then they touch just ever so slightly that edge of the glass tube, and that tension, right, from the liquid to the solid tube breaks that surface tension of the liquid, and it falls down into the media and travels along the edge of the glass. So if you think of cohesion is a good scientific vocabulary word, as these two surfaces meet, adhesion and cohesion are good properties to know in fluid dynamics. And so we can continue to see that fixative filling up that tube and reaching up even to that plant up on the upper right-hand side, which we called Ronin, and getting some fixative onto it as well. So King Cobra is now fixed into that tube, and Ronin is fixed, and Oz is fixed, and so it continues to fill up. And so this just leaves us with tube 1, and we still see some green plants developing over there. So we haven't made the call yet for the fixative to start in that final tube.
And just as a reminder, Lori, we're putting the fixative in for what purpose? What do we hope to do with it?
So we are trying to keep the plants in a current status, right? We fix them while they're in orbit so that once the box is unplugged and powered down, that there won't be any further change in the plants. We won't see them decay or degrade or any other changes. And so this fixative will enable us the time it takes to get back to Earth and transported back to us through our flight provider so that we can do microscopy. Now, I would love to know if you type in the chat, if you have access to a microscope in either your classroom or even your home. Some people have them, because we are going to be doing post-flight science by looking down in the microscope of what happened at the cellular level with these plants. What do we observe when we take cross sections of the nodules or the leaves and the stems and the roots? So the air, there's a good question, where does the air go when the fixative goes in? The air is pumped out. One of the engineers through the Cube Lab told us last week, actually, there's a way for that air so that it's not compressed, right? Because that would just, we thought maybe there was a compression issue over in tube 3, but it turns out that some of that air is taken out of the tube and it fills a bag, I believe, one of the empty juice boxes.
That's right, just under the juice box, that's right. All
Yep.
right, so get those microscopes ready. In just a couple of weeks, we're going to be getting back, coming back home to Earth on the SpaceX Crew Dragon 1, which is going to be really exciting. The date is not firmed up, but it was going to be early May. Now we understand it's going to be late April. So just in a couple of weeks, we'll be seeing that happen. And Lori, I'm not sure if we're planning another session for next week. I think we should probably keep it running since we're pretty far along. Yep. And we'd love to hear from other students and other classes if you hadn't had a chance to share this week, or if you have something new that you discovered between today and next week, by all means, let us know about it. But we're really excited about the progress you guys are taking here on Earth while our plants are floating around in microgravity. How awesome is that?
Yeah, South Africa is preparing a presentation for next week.
Oh, that's great.
Perfect.
They have some big announcement too.
Oh,
okay.
All right.
Great. Well, for everyone who's been on today, if you have work you've seen, the progress from other students and the way they've tracked their experiment, feel free to put together a few slides if you want, or just to bring your artwork and show us, or your observation log as you've been writing things down in a notebook. Or even just within your account on the Magnitude platform. You can even use that as your visual if you want. So let us know if you would like to be on our agenda for the next edition of Legumes in Space Live. This is a real time to collaborate and to share what we know. We really heard today that positive effect on nodulation using magenta light. We'd like to continue to know from you, is that what you're seeing in your ExoLabs too? I think that is kind of the time we have for today. We're a couple minutes over, actually. So we are going to sign off for today. Thank you for joining us.
That one more time, that Legume in Space with everybody. We got the little practice down the beginning. Let's see if we can pull it off together.
Okay, here we go. 3, 2, 1.
Legume in space.
Wonderful. Have a great week, everyone. We'll see you next week.
See you next week. Cheers.
Bye-bye.